All right, guys, hopefully this helps you get ready for the test. I just want to point out all the formulas at the top. You will have these on your test as well, but I want to make sure you know which ones are which. So these first two here are the arithmetic. This one here is recursive. This one is explicit. If you don't like it this way, you're welcome to put the D back here. It's the same thing, doesn't change anything. So that's up to you. I taught it to you with the D at the back. This has the D in the front. I think on the test it'll be in the front. So maybe just keep doing it this way. The next two are these two here are geometric. This is the recursive, and this is the explicit. Okay, and then these are sums. So this is the sum of an arithmetic series. All right, this is where we're adding. These are sequences, if that helps you. Those first two are sequences, first four. So the sum of an arithmetic sum. These two are geometric. So just remembering which is which. You have your finite geometric series right here. And then you have your infinite geometric series for that one. Okay, so all these formulas that you're going to be using, you need to know what they are. So make sure you know which one is which. Okay, starting with number one here. It says, given the sequence, find a recursive formula and, excuse me, an explicit formula. So what I would do first is just take a look at what's going on here. So to get to the next one each time, remember the way you can figure that out is do the second number minus the first number, or the second number divided by the first number, and see what keeps happening. So 6 minus a negative 5 is a positive 11. 17 minus 6 is a positive 11. So we're adding 11 each time. So your recursive formula would be a sub 1 is negative 5, and a sub n equals a sub n minus 1. Remember, that never changes. That's always going to look like that. And then you just have to do what's happening, which is plus 11. Okay. The explicit formula, you have your a sub n equals, and then it's your a sub 1, so negative 5, right? I'm using this formula right now. So the negative 5 plus, now you can do n minus 1 times d or d times n minus 1. It does not matter. They are the same thing. So your d is 11, your n minus 1 is here, so we're going to distribute that. Negative 5 plus 11n minus 11. And simplify that one step further then. So you get 11n, negative 5 minus 11 is a negative 16. So the explicit formula is this. When they ask you to find a of 22, they're saying what's the second term, 22nd term. You do not want to use the recursive. You want to use the explicit. So we're going to say this formula right here, we're going to plug in a 22. So a of 22 equals 11 times 22 minus 16. So a of 22, if you plug that into your calculator, you get 226. Okay. Then it asks us to find the sum of this series. And we already have our explicit formula. And we know our last term. Up here is that 479. So that 479 goes right here in the formula. So we're going to say 479 equals 11n minus 16. So add 16 to both sides, and you get 495 equals 11n, and then divide by 11. So n comes out to 45. Okay, so that's our n. We're trying to find the sum. The sum formula for an arithmetic is this one. So we're using that formula. So it's going to be s sub 45 equals 45 over 2 times the first term, -5, plus the last term, 479. And then you'll just plug that into your calculator. So the sum of those 45 terms is 10,665. Okay. Feel free to pause me and rewind me if I'm going too fast for you. Number 2, given this sequence, find a recursive formula, an explicit formula, the 10th term, and the sum of those 10 terms. So a recursive formula, you take your first term, which is 3, and then you take a sub n equals a sub n minus 1, and we got to figure out what's happening here. Okay, so to get to the next one, take 6 divided by 3, 12 divided by 6, or take 6 minus 3, 12 minus 6. What happens constantly is that we're multiplying by 2. Okay, so this is going to be times 2, and that's your recursive formula. Your explicit formula is a sub n equals your first term, which is 3. Let me just point out to you what I'm doing up here. I'm doing this one right now. So this was the first one. Now we're doing the explicit. So it's 3 times your common ratio, which is 2, to the n minus 1. Do not make that 6 to the n minus 1. You have to do the exponent first before you multiply. Okay, so if I want my 10th term, then I'm going to plug a 10 in for n. So this is going to be a sub 10 equals 3 times 2 to the 10 minus 1. So that's 3 times 2 to the 9th power, and 3 times 2 to the 9th power, plug that into your calculator, 1,536. Okay, now if we want the sum of those 10 numbers, okay, we're doing, this was a geometric, okay, so we're not doing this one. We're doing the sum of a set amount, not to infinity, okay, it's not this one, so we're going to do this one. This is a finite geometric sequence, or series, sorry, not sequence, series. So this one is going to be our first term, which is 3, times 1 minus our rate is 2, to the nth power, and we're doing the 10th, right? Our n is 10, so that's going to be 2 to the 10th power. Don't forget your parentheses here. Divided by 1 minus our rate again. Make sure you put those parentheses in. So this is going to be the sum of those 10 terms. Plug this into your calculator, and you get 3,069. Okay. Moving right along. Write the first 4 terms of the arithmetic sequence. Remember, arithmetic means we're adding something each time. So they tell you the first term is -10, and then your common difference is -2. That means you're adding -2 each time. So -10 plus a -2 is a -12. -12 plus a -2 is a -14, and -14 plus a -2 is -16. That is your answer. Okay, first 4 terms. Arithmetic, meaning you're adding. Don't multiply by -2. It's a common difference, right? Adding and subtracting. Okay, number 4, first 4 terms of the geometric. Now we're multiplying. So for this one, if our first term is -4, then you're going to take that and you're going to multiply it by a -1/2. So -4 times a -1/2 is going to get you your next term. Well, that's going to be a +2. Okay, now you're going to go 2 times a -1/2. Multiply that, you get -1, and then we're going to do -1 times a -1/2. And now your next term becomes a +1/2. So these are the first 4 terms of that geometric sequence. All right, number 5, find the arithmetic mean. Arithmetic mean is the one where you take the 2 numbers and you add them together and you divide by 2. So this is going to be 12 plus 56 divided by 2. When you simplify that, that comes out to 34. Okay, where does geometric mean? That's where you take the two numbers and you multiply them and then you square root those. So this is going to be 62 times 992 and take the square root of that. That comes out to 248. All right, number 7, find the first 4 terms of the sequence. These are just going to be more plug and chug type problems. So my first term, a sub 1, is going to be 5 times 1 times 1 plus 3, right? I'm just plugging ones in place of my n's. My second term is going to be 5 times 2 plus 3. My third term is going to be 5 times 3 plus 3. And my fourth term is going to be 5 times 4 plus 3. So simplify each one of those and you will have all of your terms. So this is 5 times 4 is 20. 10 times 5 is 50. 15 times 6 is 90. And then 20 times 7 is 140. So your first 4 terms are 20, 50, 90, 140. Okay, of the sequence. Letter B, this one still find the first 4 terms. So we have our first one, which is lovely. A sub 1 is 8. A sub 2 is negative 3 times the term before it. Remember, that means the term before it. So that's where we take our a sub 1, because it's a sub 2 minus 1 is a sub 1, right? Plug in our a sub 1, so plug in an 8, and then add 2. So our a sub 2 is a negative 22. Then our third term is negative 3 times the term before it, so negative 22 plus 2, and we get 68 there. And then our fourth term is negative 3 times the term before it, 68, plus 2, and we get a negative 202. Okay, so if you want to write that as a sequence, it would look like this. All right. All right, next page. Here's all those formulas again at the top. Use them. They should be very helpful for you. Number 8, it says write this in summation notation. Find the sum or the difference. So summation notation, remember that's the one that looks like this. You're going to start with n equals 1 because this would be our first term. And then we don't know what number goes here, what term number that is, so we're going to have to solve for that. The way we do that, and we also have to solve for this, our explicit formula. So we're going to set up the explicit formula. We're going to say a sub n equals our first term, negative 5, right? That's this guy, plus n minus 1 times our d. And you got to figure out what d is. So if you go negative 2 times negative 5, 1 minus negative 2, 4 minus 3, every time that works out to a positive 3. So we're adding 3. So multiply by 3 here. And then we would, distribute that. So this is a sub n equals negative 5 plus 3n minus 3. So a sub n equals 3n minus 8 when you combine your negative 5 and negative 3. So that is your explicit formula. 3n minus 8 goes right there. Now we need to figure out what is n. How many terms do we have? The way we do that is we take our last term. Remember, this is our a sub n. So we're going to drop that in right here. It's going to be 103 equals 3n minus 8. So add 8, and you get 111 equals 3n, and then divide by 3. So 111 divided by 3 gets you 37. Okay, which is what goes right up here. So summation notation should look like this. And then from there, actually that's all we had to do. No, we didn't. Find the sum. They want you to find the sum. So to find the sum, let me erase some of my lines here so I can fit the sum in here. To find the sum, you're going to do that sum formula again. So the sum of these 37 terms is going to be 37 divided by 2 times the first term, which was our -5, plus the last term, which is 103. So this is going to be -5 plus 103, and that you can plug into your calculator. So the sum of those 37 terms is going to be 1,813. Okay. Number 9. This says if a of 1 is 17 and d is -4 and n is 20, find the sum. Okay, well, in order to find the sum, because this is a common difference, this is arithmetic, right? So we need this to find the sum, which means we need to know what n is, and we do. So those are taken care of. We need to know a sub 1, we do, that's this guy. And we need to know a sub n, and we don't know that one. So we're going to set it up as the arithmetic formula, the explicit formula for an arithmetic sequence. So the way we do that is we say a sub n equals a sub 1, 17, plus n minus 1 times the common difference. Okay. Oh, and I didn't plug in our n. We know what n is. N is 20. So we're going to plug that in right here. So that's going to be 20 minus 1. So that means if you plug that into your calculator, that's an n, sorry, not an m. A sub n equals, plug this into your calculator, 17 plus 20 minus 1, use the parentheses there so you get the right thing. What you get for a sub n is a -59. So if a sub n is -59, then when we want to find the sum, we use this sum formula. The sum of the 20 terms is going to be 20 divided by 2, n divided by 2, times the first term, 17, plus the last term, -59. And again, plug this into your calculator just like you see it. You get the sum of those 20 terms is -420. Okay. Moving right along. Number 10. This is arithmetic. Okay. They tell you at the top it's arithmetic. So given this setup up here, we want to know how many terms does it have? What's the first term? What's the last term? And what's the sum? So the number of terms, remember you take this number minus that number and add 1 to it. So 50 minus 1, but then add 1, that is 50. Again, if this starts at 1, whatever is here is your number of terms. Okay? So our number of terms here is 50. The first term is us plugging 1 into our formula. So 3 times 1 minus 9, or 3 minus 9 is -6. That is our a sub 1. That's our first term. Okay, so -6 for our first term. The last term is us plugging the 50 into our formula. So 3 times 50, 3 times 50 minus 9. So 150 minus 9 is 141 for our last term. So then to find the sum, we're going to plug those things into the sum formula. So the sum of those 50 numbers is 50 divided by 2 times the first term plus the last term. And when you plug that into your calculator, 3,375. Okay. Number 11 says write the first 3 terms of the infinite geometric series if r is 0.4 and a sub 1 is 28. Okay, so if r is 0.4, that's a common ratio. We're multiplying because it's geometric. So you're going to go 28 times 0.4 to get your next term. So that comes out to 11.2. Okay, then you're going to take 11.2 and multiply by 0.4, and you get 4.48. Okay, notice this is an infinite geometric series, so we are using this infinite one, a sub 1 over 1 minus r. So if we do a sub 1 over 1 minus r, a sub 1, that's our first term, is 28, over 1 minus our rate, our ratio there, which is 0.4. And don't forget to put parentheses around that if you're just going to plug it all in as one shot. So our sum comes out to 46.6 repeating, or 46 2/3. That's what it would add up to. All right, number 12. For this one, it's summation notation. Notice this is very simple. It goes from one term to three terms. So you're just going to plug in a 1, and then a 2, and then a 3, and add them together, right? Sum means you're adding them together. So we're going to go 1 squared plus 1 plus 2 squared plus 1 plus 3 squared plus 1. Okay, so simplify that. 1 squared plus 1 is 2. 2 squared plus 1 is 5. And 3 squared plus 1 is 10. So 2 plus 5 plus 10, you get 17. Okay, letter B here. And again, technically you could just plug these into your calculator as well. But I'm going to show you the fancier way because, you know, it's good for you. So for this one, we're saying it starts at term number 4 and it goes to term number 9. So the fourth term here would be if I plug in a 4. So negative 10 times 4 is the fourth term. Negative 10 times 5 is the fifth. Negative 10 times 6 is the sixth. Negative 10 times 7 would be the seventh. Negative 10 times 8 would be the eighth term. And negative 10 times 9 would be the ninth term. So if you simplify that, negative 40 plus negative 50 plus negative 60 plus negative 70 plus negative 80 plus negative 90, work that all out, you end up with, what does that come out to? Negative 390. And again, if you plugged it into your calculator, you would get the same thing. Remember, if you're going to do the calculator way, you hit, you hit math, hit the math button, and then 0. And then type in all your pieces. Okay, number 13. Find the sum of the first 250 numbers. So for this, if you think about it, you're saying the sum of 250 numbers. Well, if it's 250 numbers, that's going to go here. And then your first number is 1. Your last number, if it's 250 numbers in a row that we're adding together, that last number would be 250. So you can just set it up like this, 250 divided by 2 times 1 plus 250. You get the sum of those 250 numbers is 31,375. Okay, number 14 says write the arithmetic series using summation notation. So that's going to look like this for 25 terms. So if we start at the first term and go to the 25th term, that's going to look like that. And they give you the first 3 terms here. So if you look at what's happening, they tell you it's arithmetic, which means you're going to be adding something each time. So if you look here, 17 to 29, that was plus 12. 29 plus 41, that's plus 12. Remember, how you can figure out that number is you take the second number minus the first number, or you take the third number, 41, minus the second number, okay? Each time you get 12 there, so you're adding 12. So what we're looking for now is what is our explicit formula that needs to go here, because they just want us to write this in summation notation. You don't even have to find the sum for this one, okay? So we would say explicit formula, a sub n equals our first term plus n minus 1 times our common difference, which is 12. And then we're just going to simplify that. So this is going to be 17 plus 12n minus 12. So a sub n equals 12n. 17 minus 12 is a positive 5. So your explicit formula, 12n plus 5, goes right there. And that is your summation notation. Okay, number 15. This one, I'm going to leave some room off to the side here because I want to write down kind of a picture for you. It says a 50-row theater has one aisle. So think about the theater has an aisle here and then all the seats on both sides. Okay. Both sections have 25 chairs in the first row. So there's 25 chairs in this row and 25 chairs in this row, and 3 more in each succeeding row. So if you think about that, your first term, your a sub 1 for this setup, is going to be 50, right? This first row of seats has 50 seats. Well, if each row after that has 3 more in each row, so that would mean that there's plus 3 on this side and there's plus 3 on this side. So we're taking plus 6 for each row. That means our common difference, right, what we're adding each time is 6. So we're adding 6 seats to each row. Excuse me. It says find the, seating capacity of the theater. So to do that, just realized my microphone was in the wrong spot. Hopefully you heard that okay. To do that, we're going to start with the explicit formula, which is going to be, oh, one more number. Where is this? A 50-row theater. That is our n. That's how many terms we have. 50 rows, 50 terms. Okay, so we are going to start by doing the explicit formula. So a sub n equals our first term, 50, plus n minus 1, n minus 1, times the common difference, times 6. So plug that in. If you plug this all into your calculator, how you see it, you will get a sub n equals 344. So if we're trying to find the total seating capacity, we're trying to find the sum, right? So we're going to use our sum formula. So it's going to be the sum of the 50 terms, the sum of the 50 rows is going to be n divided by 2. So 50 divided by 2 times our first term, 50, plus our last term, which we just found, 344. And plug that into your calculator, you get a sum then of 9,850. Okay. Last one. It says the first term of a geometric series is 5 if there are 10 terms and r is 2. What is the sum? So think about what that means formula-wise. It says the sum, okay, so we're going to be using one of these, of a geometric series is 5. There are 10 terms. So it's not an infinite geometric series. There are 10 terms. We're going to be plugging a 10 in here. So we're going to be putting it into this formula. I'll just rewrite that down here so you can see what I'm doing. So sum of n equals a sub 1 times 1 minus r to the n over 1 minus r. Okay. So when we plug this in, it says the first term is 5. That's going to go here. So the sum of 10 terms, sum of 10, equals 5 times 1 minus our rate. Our rate is our ratio. Common ratio is 2. To the n power. Well, we already said n was 10. So to the 10th power over 1 minus our common ratio. Now, you want to make sure that this gets in parentheses and this gets in parentheses. It really doesn't matter if this whole thing does as much. So you would plug in 5 times parentheses 1 minus 2 to the 10th parentheses divided by 1 minus, oh, I wrote 2r instead of 2. Sorry, this is a 2. So if you plug that into your calculator, you should get the sum of those 10 terms is 5,115. Okay. If you can do this stuff, you can do what's on your test. So just keep in mind, you need to know what these formulas are, but you don't need to have them memorized. I will give you all the formulas. You just need to know when to use which one. So maybe go back up here and just make sure you know all of this information for those formulas. Okay.